Hello everyone, we are on day 6 notes. The topic for today is what we call multiplicity, and then from the given information we're going to sketch a graph. So whenever I say multiplicity, I'm not going to write it out every time, but you'll see what I mean in a second. Anyway, getting ahead of myself. So the instructions say, given the function in factor form, we can use these factors to determine the zeros in the multiplicity. So side note, just pause for a moment and think back on this word zero right here. You should know several other words that mean the word zero. For example, the word root means the same thing as zero. The word solution means the same thing as zero, and the word x-intercepts mean the same thing as zero. So don't be like, oh, what is this zero thing? It's just finding the solutions. Okay, so number 1, I gave you a problem. F of x equals x minus 1 times x minus 2 times x minus 3. It's what we call factored form, all those pieces, the binomials. We've done this before. I called it the ZPP. You need to take each piece that has x in it, so x minus 1. You need to set it equal to 0. You then need to solve that piece. So this one's pretty easy. You move the 1 to the other side and you get that x is equal to 1. Okay, that means that there is one of these solutions. Okay, the reason I know that there's one of them is, see the part that I bracketed? Technically, there's a little exponent of 1. That means that the multiplicity, so I'm just going to say m because I'm lazy, is 1. So now let me do the next one. The next piece is x minus 2. So I take x minus 2, I set it equal to 0. I do a quick solving. I get that x is equal to 2. Okay, look at the exponent. The exponent is technically a little 1, so that means the multiplicity is 1. Last piece for this one, x minus 3, set it equal to 0, so you can get that 0, the solution. You solve it, you get x is equal to 3. So there's my other answer. Look at the exponent. Technically there's a 1 there, so the multiplicity would be 1. So I have 3 solutions, 3 answers to this problem. At 1, at 2, and at 3. The multiplicity is 1 for all of them. Okay, the next one is kind of sort of like that. I have x minus 2. Take that piece, set it equal to 0, do a quick solving. I get x is equal to 2. Look at the exponent. It's exponent of 1. That means my multiplicity is 1. There's only one of those answers. Let's look at the next part, and you can kind of see something is happening. See this next part? See how it's the same thing twice? X plus 3. It's happening twice. Well, I don't need to solve it 2 times. I still get the same answer, x equals negative 3. However, it's happening twice. So if it's happening twice, that means my multiplicity is 2, because there's 2 of those answers. And if the multiplicity isn't even, so multiplicity of 2, you're going to hear me say that there's a bounce. And again, we will get to that when we make the graph. But when it's an even multiplicity, a 2, a 4, that means that there's going to be a bounce. Okay? Let's do the next one, number 3. Take each piece that has x in it. So take that x, set it equal to 0. That one's very simple because x is equal to 0. Technically, that has an exponent of 1, so my multiplicity is 1. Let's do the next piece. X plus 5, set equal to 0. A little bit of solving. You get that x is equal to negative 5. There's just one of those. Exponent is 1, so that means the multiplicity is 1. Let's do the next part. X minus 1, set it equal to 0. Solve for x. I get that x is equal to 1. Okay, thing to notice here is a little bit different. I have an exponent of 2, so what do you think that multiplicity is going to be? It's going to be a 2. That means there are 2 of those solutions. That basically means, again, if it's an even multiplicity, I got to bounce. And I'll show you what that looks like when we make a graph. Okay, let's do another one. Y equals x minus 4 cubed times x plus 6. So each piece that has x in it, take it, set it equal to 0, solve it. They're pretty quick when you solve them. You get x is equal to 4. Look at the exponent. It's a little 3, so that means my multiplicity is 3. It's not even, so there's no bounce there, but it's different. It has a multiplicity of 3. Okay, last one. X plus 6, set equal to 0. solve it, I get x is equal to -6, okay? Look at the exponent. The exponent is technically a 1, so my multiplicity is 1. And that's how we would find the solutions, right? The box part are the answers, and then I clarified on the multiplicity. Okay, we're going to keep doing that, but let's talk about the graph. Okay, so it says sketch the graph of the following. I have my function. On the side it says, remember a blank causes a bounce. You could write two different things here. An exponent, I'm going to say exponent of 2 causes a bounce. Okay, just to kind of make sure you understand that. An exponent of 2 causes a bounce. Or a 4, or a 6, or an 8. An even number. But we're mainly going to see 2s. So let's go ahead and do this the same way. So each piece that has x in it. So that 0.6, it doesn't matter. It doesn't have an x. So move on to the x minus 2. Set it equal to 0. Solve it. I get that x is equal to 2. Look at the exponent. It's technically a 1. That means the multiplicity is 1. Okay, let's do the next part. X plus 3. So I take x plus 3. It equals 0. Solve it. I get x is equal to -3. Look at the exponent. That's going to be a little different. That means I have a multiplicity of 2, or what we just talked about on the side there. I'm going to have a bounce. So I just write it so I don't forget. Okay, so the first one, I have a multiplicity of 1. The other one, I have a multiplicity of 2. So in total, my multiplicity is 3, right? 1 plus 2. If my multiplicity is 3, that means my degree of my function is 3, which means if I have a degree of 3, I have a cubic function, okay? If it's degree 3, I have a cubic function. And look at the very beginning of this problem, like right smack dab in the beginning. Is it positive or is it negative? It is a positive number. So I have a positive cubic function. And if you go back to the graphs that Ms. Hope talked about in a previous video, positive cubic graphs look, something sort of like that shape. So we are going to mimic that shape. So I have some solutions that I need to work with. I have a solution at +2. So I need to put a solution. I'm going to put a red dot. Let's do a giant red dot. I have a solution at +2. And I also have a solution at -3. Let's do a giant blue dot. Okay, so there's my solutions, right? My red solution and my blue solution. Remember, I'm mimicking this cubic graph. So I'm mimicking that. So I'm going to start up over here. If it's a multiplicity of 1, I get to pass through that point. And then I'm going to kind of curve over and find the next solution. So I find that blue dot. If it has a bounce or a multiplicity of 2, I cannot go through it. I bounce off of it and head downward. So the red one I got to pass through. But if there's a bounce, I bounce, like think of a bouncy ball or a trampoline. You bounce off of it in that same direction. And that would be how we would create the graphs. Okay, let me get to the next example. 2 more kind of like this. Sketch the graph. Let's take each piece. Let's see what we're dealing with. Each piece with x in it. Set it equal to 0. You got to divide by 2. I get x is equal to 0. My exponent is 1, so my multiplicity is 1. Okay, let's do the next one. X minus 3. Set it equal to 0. I get that x is equal to +3. Okay, oops, I almost forgot. Multiplicity is 1. And then this last piece here, x plus 4. Set it equal to 0. Solve for x. I get x is -4, and this one is unique. It has multiplicity of 2, which hopefully you're thinking, okay, there's a bounce. And then I have multiplicity 1, and multiplicity 2. So if I combine those all together, that gives me a total of 4. If it's a 4, degree 4 means I have a quartic graph. And look in the beginning of this problem. Is that beginning a positive number or a negative number? This one is positive. So if you think back again to Ms. Hope's video on the shapes of graphs and things, if it is a positive quartic curve, it's going to look something like this W shape. So I'm going to mimic that shape. I'm going to be a little bit more specific because I have solutions. First off, I have a solution at 0. So I'm going to put a red dot at 0. And then I have a solution at 3. So that one gets a blue dot. There's my solution at 3. And then I have a solution at -4. That one gets a giant green dot. Let's get that green dot. Okay, those are my 3 solutions, right? It's very extreme with the dots, but you see it. I'm going to start making this W shape, right? I kind of mimic that shape. I just have to be careful with the bounce. So I'm going to go ahead and start. It doesn't matter where you start. I'm going to start over here on the left, and I'm going to go to that green dot. I bounce on that dot. I don't go through it. I bounce over it, and I find the next dot. That red dot is nothing special, so I pass through it, and I find my last dot, my blue dot, and again, nothing special there. I get to pass through it, and I end going up. But see how it's not perfect, but it still kind of has that W shape. Okay, my last one. Sketch the graph. F of x equals x. Let's just do it as I speak here. Take each piece that has x in it, set it equals 0. So my solution is x equals 0. Multiplicity, again, is 1. Then it's being multiplied by x plus 4. So let's take x plus 4, set it equal to 0. Get that solution. That's -4. Multiplicity is 1. And then this last one here is x minus 6. Ooh, let's do a better color. X minus 6. Set it equal to 0. I get x is positive 6. Again, multiplicity here is 1. Oops. Okay, if I have multiplicity 1, multiplicity 1, multiplicity 1, that's a total of 3. So if the degree is 3, that would be a cubic graph. In the very beginning, do I have a positive or a negative? In this case, it's technically a positive 1. So if I have a positive cubic graph, it's going to look something like that shape. Again, I'm going to mimic that shape. I need to put these solutions on. So my first solution, again, let's do a red dot at 0. My next solution is at -4. 1, 2, 3, 4. I'm going to put a giant blue dot. And then my last one is at, let's see, at 6 and the positive. 1, 2, 3, 4, 5, 6. That's going to get a giant green dot. And there's my solutions. Okay, let's make this graph happen. There are no bounces, so I pass through every single point. There's no bounce, so I pass through every single point, and I keep that same type of cubic shape. And that's how you make those graphs.